All right, welcome everyone. And just please read over the information on this screen. Really important to wait 24 to 48 hours after the webinar to print your certificate. And the way you print that is in your ADE Connect account. If you go to completed here, you'll be able to print certificate. Sorry, it's a little blurry. All right, welcome to those just joining. We are going to get started right at 4 p.m. Just please read over the information on here so you know how to receive your hours. And after the webinar, there will be a survey that will go to your email. And that's how you know that I've actually put in attendance, because you just being here does not mean the system knows you were here. I have to go put that in. All right. So welcome. We are going to get started because this is a pretty involved webinar. We're really excited for you to be here. My name's Rebecca Gorelli. I'll introduce those of us on here in just a second, but I just want to make sure you understand all the information here. You will get an hour and 1.25 hours for being here. Wait 24 to 48 hours to print your certificate. We do not send them out. And you basically go into your ADE Connect account, click completed, and print your certificate. The way you know that I've marked you as attended is that you will get a survey in your email, and then I'll give you a follow-up email with some resources. So we're going to get started. You are here for transforming science learning. And this is really about the science and engineering practices using digital tools. And so my name's Rebecca Gorelli. I am the K-12 Science and STEM Specialist with the Arizona Department of Education, and I'll let Sarah introduce herself.
Perfect. Thank you. Good afternoon / evening. Welcome to today's webinar. So our goal at the department is really to increase our teacher capacity across the state in relation to standards. And so we work in quite a bit in relation with each other in collaboration with creating these learning spaces. So thank you for being here with us today.
Yeah, great. Thanks, Sarah. All right, let me just click this. Here we go. All right. And so let's just take a moment. I do recognize a lot of your names, so thank you to those who have returned. But just find the chat box, put your name, your position, and what county. We love seeing all the different counties that come to join us in this learning space. So in the chat box, go ahead and introduce yourself. Yuma, Maricopa, awesome. Great, welcome. Pinal, Maricopa, Navajo. Thank you for joining us. This is fantastic. All right, and I'm just going to gently push us along. Really fun to see all the different counties represented. And I'm just going to go over a couple of housekeeping things. And if you're still writing in the chat, that's okay. We are going to use the chat function a lot. Just make sure it's turned on to everyone. And please stay unmuted for, keep muted for now and keep your video off. I tend to have some weird internet issues after 4 p.m. where I live. I don't know why. So if you see me go with my video off, it's because my connection is unstable. So at the end, though, we do have time for Q&A where you can unmute yourself. So welcome. And we're going to spend a little bit of time orienting ourselves to what we call the dashboard. This is a tool that Sarah just put in the chat box. And what I need you to do is to click on the link that's in the chat box. But when you click it, it's going to look like this. And so you do not want to open with Google Docs. It is not a Google Doc, it's a PDF. So I need you to download it. So go over to the arrow, download it as a PDF, and then open it so that you'll be able to click on all of these links. If you open with Google Docs, it's gonna jumble it all up and it's gonna look like a hot mess, and we don't wanna do that. So do not open with Google Docs. Go over and just download it and then open it, because this is where we're going to house all of our materials for this learning experience. And if you notice here, you'll see that there are some that are grayed out. The ones that are grayed out are the ones you need to specifically pay attention to, because those are the ones we're actually going to open and we're going to write on and we're going to collaborate and we're going to use together. So what I need to know is when you have oriented yourself to the dashboard, and I mean you downloaded it as a PDF, put in the chat box done, because I cannot go on until I know everybody is good to go. So once you downloaded, you got it. Okay, I see some dones. Thank you. Perfect. And if you're
Rebecca,
just—
do you want to give the reminder about the PDF just one more time and how to download it? Because I just put a bunch of people that were in the waiting room into the webinar.
Okay. So if you just joined us, Sarah put a link in the chat for the dashboard. The dashboard looks like this. When you click that link, it's going to open like this. Please do not open as a Google Doc, because it's a PDF. So do not click this. It's going to mess it all up and it's going to look weird. Come over here and just download it and then open it and then put done in the chat box so that I know you have it, you're ready to go. These are all the links of everything that we're going to do today. The gray ones are the ones we're actually going to open. The rest are just resources that I'm going to kind of refer to over the learning experience. And I'll wait to see more dones in the chat box. Let's see. Scrolling through. Okay. Okay, looks pretty good. All right, and Sarah will be watching the chat. So like if you need a little assistance, just put a note in there and reach out to Sarah and she's happy to help you. Okay, so I feel like we have a lot of dones and everybody is ready to go. I just wanted to kind of talk about where we are in this learning experience. This actual webinar pathways is something we just developed over winter break to kind of explain to the field, like, if you're new to three-dimensional instruction, these are the webinars you should probably go to. If you've already kind of, gone to all of these and you feel confident, then you come to box 2. We are in box 2 right now. So if you are like in this learning experience going, I don't know a lot of these things, it may be because I'm assuming you have this background knowledge of what three-dimensional instruction is. And so today, this is kind of like a step up from the basics. And so I'm going to assume a few things. I'm going to assume you've heard of three-dimensional instruction, you know what the 3 dimensions are, and you have a little bit of knowledge about what they are in terms of planning. So Sarah's going to come in and just talk about ADE announcements super fast before we get into the actual webinar.
All right, here we go. I just wanted to give a little shout out to, it is the Presidential Awards for Excellence for Math and Science Teaching, and it also could be for computer science or engineering. It covers that whole STEM package. So this year's cycle for the Presidential Awards are for 7th through 12th grade educators to apply. You can nominate yourself, you can nominate someone else. And the nomination period will end on the 1st of March. And so what happens is that you go through a process, you write up a write-up, you create a video, you go through, it takes a little bit of time to do, but at the end of the day, once you've gone through all of those, we look at them, we have a committee that comes together, and then the final awardee goes to this, our final finalist goes to the state level, and then this, then at a national level, they choose an actual state awardee for math and for science. And that person earns $10,000 and also travels to DC to meet the president. So that's part of that. So I just wanted to share that opportunity that's out there with you. And then on the right side, just to share a 2020 year review we put together, one of our big goals this year. And even with COVID, we had a lot of people that wanted to come to PD. So we have 58 different webinars that we've done, with Rebecca doing them, or in partners with some of our partners with ASTA and with Sensemaking project. And so we just wanted to kind of share some of our highlights for this last year.
Perfect, thanks.
I will be here, so if there's anything you need, and I will kind of check in, and you can message me alone or message me to the group as well.
Thanks, Sarah. All right, and this webinar is built using 2 presentations from the National Science Teachers Association. We asked permission, so we just wanted to give them a shout out and say thank you. And so I'm going to invite you to just read over the goals. All right, so we are going to collaborate using digital tools, and our whole focus is the science and engineering practices. So let me just get my notes up quickly. Here we go. All right. And again, if you need anything, Sarah is available in the chat. And so I'd love to start us off by just thinking about our community norms, which are like our shared agreements in this space. Whether we're face-to-face or in like a virtual learning community, it's important that we honor each other and all of our voices. Equally important, though, is that we actively and respectfully listen and speak to one another. And finally, I'd like to remind everybody here that it is important to commit to the group by contributing to the learning of others through active participation. So be active in the chat window, ask questions, answer someone else's question. If you're kind of moving along in your learning and you have something to contribute in the chat, please feel free to do that. And really, if you want to push back on someone's idea also and offer a different idea, that's okay as well. And so let's all just commit to being active participants today. And so just thinking about why we're here and why we're engaging in this productive struggle today, our goal is to provide access to science literacy for all students that are in front of us. Our new science standards are based on the K-12 framework for science education, which is a contemporary piece of research that helps us understand how students learn science and helps educators ensure that we provide access to all learners to engage in science learning. And the way that we provide that access to all of our students is to be thinking about what's called sense-making, which comes from the K-12 framework for science education. And it's really about providing opportunities to make sense of the world around them. So before we get started tonight, let's kind of frame 2 labels of instruction. On the left here, you can see I have something called the information frame. This is sort of the way many of us grew up in science, where the teacher is the explicit instructor, right? Providing facts and materials, and the assessments are just focused on the right answers, where it just really looks at science and, as a portrayed as a body of established facts. And it's just about disseminating information. So that's the traditional way, which we are now moving away from into what we call the sense-making frame. So if you look at these like on a spectrum, they are on complete opposite sides of the spectrum. So where we're going to be in this learning experience is called the sense-making frame. We are working on conceptual understanding, you constructing knowledge with others. And it's about making sense of the world. And we have to provide evidence to support our thinking. So the shift is what we call with our new standards from knowing about to figuring out. And so really this design here, although it says distance learning at the top, this is really 4 components that should be part of every learning experience for students. There are critical components for sense making. So no matter if you're distance learning or face-to-face, these 4 components need to be part of the learning experiences. The 4 components are phenomena, and then we have science and engineering practices, student ideas, which means they're sharing, combining ideas, collaborating, bouncing off each other, and then classroom norms. And classroom norms are incredibly important because an established set of norms provides a safe space so students know what it means to be a member of that community and to know what their rights and what their responsibilities are to that community. And really none of the rest of these components can happen unless we have a strong set of shared agreements in our own classroom. And so educators across the state, have really different learning environments. And everyone's trying to navigate the complexity of all of this. And you can see from the color coding, if you kind of look downward, is as we advance down the learning environments to the asynchronous learning. it really does get tricky, and the complexity is more and more challenging. And so for today's experience, we have chosen some digital tools, but they're intentional. I'm not specifically recommending that you use exactly what I did. If you like it and it works for you and they're tools that your students are used to and can dive into, great. But remember, when we choose digital tools, it's about the purpose and the features of that tool, not to just show them something new and shiny and say, oh, we're going to just keep trying another digital tool and another one. You really only need a couple that'll work and the kids know how to use well, that'll get to the purpose that you are striving for. And so, Sarah, can you help me mute people? Okay, thank you.
Different device are you using?
Okay, thanks. And so I just want to refresh your memory. Here are the science and engineering practices. There are 8 of them. They are numbered, but that's just an arbitrary numbering system to help us identify them. It's not a hierarchy or sequence or anything. So let's talk about where you're at in your own practice. And in the chat box, here is a spectrum. Are you an A, B, C, D, or E? Take a moment and reflect and think about it, and then put it in the chat. All right, so we have some folks down in the B area. We have maybe a couple over in C and D. We have some new folks. That's great. All right, perfect. And so no matter where you are on this spectrum, our goal is to continue to push folks and continue to progress every webinar we do. And so we're going to inch our way towards that E side of the spectrum. So thank you for being honest and engaging in the chat around that. All right, so let's talk about the practices, because we're going to spend our time working in the practices. Really, the practices can be grouped into 3 categories, and the 3 categories are investigating, sense-making, and critiquing practices. All of these practices, though, begin with observing events in the natural world, which is called phenomena. Anything that I can observe in the real world, it is our job to figure out what's causing that thing to happen. So the phenomena is actually the effect of something happening, and our job is to figure out what's causing that to happen. And so once we've engaged students with a phenomena that happens in the real world, we then move towards investigating practices, which are these 3. And these practices focus on asking questions and investigating the natural world. And the products of these practices are data. So we're going to have all this data. After we've gathered this data, we're going to have to start to make sense of it. That's where these practices come in, these 3. The sense-making practices focus on analyzing that data and then looking for patterns and relationships to construct explanations or models. That's the product here. So we've moved from data to starting to construct explanations and models. And the critiquing practices are these 2. These emphasize that students need to compare, contrast, and evaluate competing explanations and models to make sense of the world around them. And for us today, there's a few practices that we're going to focus on. We're definitely going to focus on asking questions, models, analyzing, interpreting data, and we're going to do a little bit of constructing explanations, all kind of together in one learning experience. Because remember, just because your standard may call out one practice, that does not mean that's the only practice you're going to engage in. They naturally connect, as you noticed in the last slide. So you're going to engage in more than one. And the learning experience I've chosen for today is from NSTA. If you haven't seen these resources, if you're an NSTA member, so National Science Teaching Association, these are amazing resources. They have elementary, middle, high school, and family connections, all built on phenomena with those 4 components we talked about. Phenomena, science and engineering practices, student ideas, and classroom norms. And so there are free versions of them, so don't think you just need to be a member. They do exist, and I did put them right here in number 3 in your dashboard. All the daily dues can be reached here. The specific daily due, which is like a sense-making lesson, we're going to dive into this one. Why does the ice melt faster? So just wanted to show you that I've already given you the links to get to those resources. And why are these good? Well, these daily do lessons have everything you need for sense making. They also have family connections. They have phenomena. They have student engagement and building ideas collaboratively, either in models or Jamboards or Google Docs, a bunch of different tools. And there's guidance for teachers. There's questions you can ask the students, etc. And so we're going to do this one called Why Does the Ice Melt Faster? And it's actually connected to this standard in our Arizona standards. So let's break it down. First of all, I'd like you to just read it. Just read the standard. Okay. So as you can see, we have construct and explanation. Every single one of our standards starts with a science and engineering practice. It's bolded and underlined. The first thing I do when I sit down to plan is I look at these coding. This is called the core ideas, which is one of the 3 dimensions of science instruction. So P4 relates to core idea P4, and U1 means I'm going to be engaging students in investigations, gathering, modeling, all of that sense-making stuff. So just read over the core idea really quickly. So we're going to be thinking about energy transferring. This is about energy transfer. And so that's the first dimension. The second dimension is already called out for me. It's construct and explanation. However, I know that constructing explanations does not mean I am only going to. I think you just muted me, actually. Can you guys hear me? Okay, thank you, sorry. All right, so this science and engineering practice, constructing explanations, does not mean that's the only one I'm going to engage with. For this, in order to construct the explanation, I'm going to have you engage in developing and using a model for your explanation. So those are really naturally connected. I'm also going to involve you in asking questions because that naturally comes after engaging with a phenomena. And we're going to analyze and interpret some data. So really, I'm going to be hitting on these 4 practices just in this one standard. And then the third dimension, which is the cross-cutting concept, we're going to look for patterns in our models, patterns in our data, which is going to lead us to wondering more things and asking more questions. So here are the 3 dimensions that we're going to engage in right now. So throughout this experience, if you see this hat, you're kind of thinking like a student, acting like a student. You see this one, little bit of student, little bit of teacher. If you don't see a hat, it just means we're in teacher mode. Reflect on that and think about how you would do this as a teacher. And so here's where we're going to start. We are going to engage in a phenomena watching this video. But to do that, what I need you to do, and you can choose to write this on paper, or if you want to go to the dashboard, this is number 5. So for number 5, you can click this and it's going to open this table already ready to go. You're just going to make a copy so that you always have it. And here is the table where you're going to collect and gather your first kind of wonderings and noticings. So you can write it on paper if you want to, or click on number 5 in the dashboard. And if you need support, Sarah is in the chat box for support. But just go ahead, click number 5, make a copy, and you should end up with this to write in. Okay, if you are ready, I need you to write ready in the chat box so I know you're ready to go on. Okay, got 1 person ready, 2, 3, 4, 5, 6. And again, it's up to you. If you want to write it on paper, that's fine. If you want to use the copy, go for it. Okay, let's go on. So what we're going to do, this is our first strategy. This is called the alone zone. As you watch the video, you're going to go in the alone zone. This is a critical step in allowing students time to commit to their own thinking first before you share with a partner or share with a group. I was a coach for a few years in Chicago Public Schools, helping teachers shift to these new standards. And many times I would be in a classroom and teacher would show a phenomenon, and then all of a sudden go turn and talk to your partner. And we went, whoa, wait a minute. Kids need time to construct their own thinking first. Let them commit to their ideas. This is how we provide equity and access, is we provide the same learning experience, allow kids to think on their own first, then share with the group. So that's why the alone zone is incredibly important. So take a moment. In the alone zone, once I show you the video, you're going to start here. What you notice, what do you see? These are your observations, and observations can absolutely be used as evidence in the future. In the I think, what I'm looking for here, it's not about like, what do you think we're going to do next? It's about, have you experienced this phenomenon in a different light? Is there anything you can connect to in your mind? Like, oh, I saw that before. I saw it, so that makes me think this is causing what's happening to happen. So it's about, you know, connecting to prior thinking or prior experiences. Okay. So next is questions. Here is where you're going to write questions. Again, that's the SEP of asking questions. And so in just a second, we're going to watch the video. So remember, observations, ideas, and then questions. What do you think is causing it? We're going to watch it 2 times. Here comes the first one. Okay. Write down your noticings. And so hopefully you're writing down everything you noticed. What are you thinking? Have you seen something like this before? Have you experienced something, a similar phenomena? And what questions do you have about what's causing that to happen? And in 5 seconds, we'll watch it again. And this time I'm going to guide your thinking. All right, when we watch it this time, think about, what do you see happening in the video? What is causing the ice to melt? What do you think? Why do you think the ice melts faster on one block than the other? What do you think is the same or different about the blocks? What questions do you have? Okay, so hopefully you filled this in. You possibly have some questions about what's causing the ice to melt. What's the difference between these materials? What are you thinking? And so what we're going to do is we're going to do what's called a noticings Jamboard. We're going to go to a Jamboard space. Hopefully you're familiar with that. If not, this is going to be a great new tool for you. And we're going to do 2 moves. And we have move 1. You're going to share your observations with the group. Now that you were in the alone zone, you haven't shared with anybody yet. So you're going to look at your I noticed section and pick 2 observations to post. Just 2. Then you're going to post them on the Jamboard. You're going to use blue for this. So if you're not familiar with Jamboard, I'll show you how to do it in a minute. And then when the posting slows down, so people are going to be putting up Post-its. When it slows down, you're going to circle an observation in your group that someone noticed that you didn't, something new, and put a check mark on one that you connected with someone else. Like, yep, I noticed that too. I'm with you. And then if you notice any patterns, you're going to put that on a green Post-it. I know this is a lot of instructions, but don't worry, they are all on the Jamboards. So to get to the Jamboard, I'll show you that in a minute. If you're not familiar with Jamboard, it's basically a whiteboard, an interactive whiteboard. I put the directions up in the left corner. There is a toolbar on the left-hand side, and we're only going to use this button. When I click this button, it's going to pop up this sticky note. And again, we're going to use blue for observations, green for patterns. And then this is the pen tool. We're going to use the pen tool to circle ones that somebody saw that you didn't, something new you're going to circle. Check mark, you're going to put on someone's Post-it for the ones that you noticed that's the same as someone else. Now this button up here, you are not going to use. You don't need to toggle. This will move you to like the next slide or frame. There's nothing, there's only one frame. So don't worry about that button at all. And so to get to the dashboard, or sorry, go to the dashboard and scroll down to number 6. And the way you're going to do this is you're going to use your birthday month. If you're December, January, click this. February, March, click that. These are all different Jamboards. So I'm just going to go to the first one to show you what it looks like. And then you're going to open it. And here's the jam. And so I'll give you a minute to orient yourself to your Jamboard by birthday month, and Sarah and I will be here in case you need us. And if you're ready, you can go ahead. Here's how you click a Post-it. We're going to use blue for observations. You're going to put 2. So let's say I noticed, and then you're going to tell us what you noticed. And then you can move these around. You can make them bigger, smaller, and just move them around. So every single person should put 2 noticings. And then when you're ready, move on to the second thing. Yay, somebody else joined me. So each person needs to put 2 noticings up. Oops, sorry to whoever that was. And as a teacher, if there's a question I have about something, I'm just going to tag it as a different color. Sometimes teachers like to use yellow. So for this person, they said, I noticed all the variables, and I just said, can you please explain variables? Like, which one are you talking about? So you can use a different color for feedback. And so let's go look at other ones and see how people are doing. And I know we don't have a lot of people. I was prepared for many more. Okay, and if you have, I see this group has started moving on to move 2. So circle 1 that someone else in your group had noticed that you didn't, and put a check mark on the ones using the pen. Fantastic. April May group is on it. Thank you. Yeah, it's going to be tricky on your phone. Yep. All right. So then if you look, are there any patterns? If you look at all your blue Post-its, are there any patterns, something that's the same, something that's sticking out, something that could, maybe think about what we could investigate next? What are people wondering about? What are they noticing? Do we see any patterns in our noticing? And if you see a pattern, go ahead and make a green Post-it and write out whatever you think the pattern is. Like, for example, if I'm looking at this one, it says one melted on the block and not the other, one melted. So right now I see a pattern of one melted and the other did not. That is a pattern I've seen in many people's now. So patterns are in green. And I know we don't have a ton of people on each Jamboard. Sometimes we have over 100 people on these. So we're just prepared. And so take a moment and think about the patterns. What do you see that people, is there something about a pattern? So yeah, on this one, same thing. One melted, one did not. That's a pattern. Every single person saw that who put it on a Post-it. So that's a pattern. All right. So this was just for our initial observations, nothing further. We're going to go into questions coming up here soon. And you could do a Jamboard for asking questions. In one of our other webinars, the driving question boards, we do questioning in Jamboard. So if you want to come see how to do that, join that other webinar we have coming up. Okay. So we have some folks getting in here. If you haven't, I know some of you might not have a ton of groups. If you want to take a look at this one, if you want to navigate back to the Zoom screen so you can see, a lot of people notice the blocks look the same. That is also, I could put that in as a pattern. So I could do, let's see, blocks look the same. That popped up many times. So that's a pattern in our observation. So patterns are green. And so, see this one, we have people circling. All right, perfect. Let's move on then. I think everybody got some patterns. You kind of get the feel for how you can do this with students. And the reason we do birthday month is because Jamboards lately, normally they can hold up to like 50 people, but lately there have been teachers who have kind of explained to us that even under 30 has been causing some issues trying to get all kids on one. So that's why we split them. You can do group 1, group 2, group 3, etc. We just went with birthday months because we don't know who you are. But if I had students, I could create group 1, group 2, etc. And then I would know who is in each of those groups. So let's come on back. Now that we've done our noticings, we now have to go to our questions. So what are we wondering? And so now we're going to do what's called a waterfall. This is another digital strategy where we're going to use the chat box only to write our questions. So here's how a waterfall works. You're going to review your own observations and everything from your group, right? So in the observations, I can kind of go back and look at what everybody's thinking. Now that I kind of have a sense, I'm going to go to my I wonder section. And I'm going to choose just one question to share, but I'm not going to hit enter. What a waterfall is right now, I want you to pick one question. Go to the chat box. You're going to type in your question, but you're not going to hit enter because I don't want kids to see what you're writing and then get an idea and not have their own ideas. I want to wait. So I'm going to give you 30 seconds to type out one question, and then I'm going to count down. And when I say 3, 2, 1, go, we're all going to hit enter at the same time, and the answers are going to waterfall. So we're going to watch the waterfall and look for trends in our questions. What do we all wonder? What do we maybe want to figure out together to move us forward in our learning? So 30 seconds right now, go to the chat box, type in your question, and then don't hit enter yet. I will tell you when. Don't hit enter yet. That's okay. It's Okay. I'm not actually mad. I just get very excited about this. All right, so you're writing your question. I'm going to count down from 5, and then we're all going to hit. And yeah, if you're used to hitting enter, there is a way to go to another line. I think it's shift or something. Anyway, we're not going to get into that right now, but I know it comes automatically. So here we go. 5, 4, 3, 2, 1. Waterfall. Hit enter so we can see. So how much is the video sped up? Is one of the blocks heated? What are the ice cubes made of? Does the ring have anything to do? I wonder what the ice cubes are sitting on, how hard this water hurts. Wondering if materials are the same. Materials, temperature. So scroll through the waterfall and look for trends in the questions. And let's think about what we all think we should investigate next. I see materials, materials, materials 4 times. I also see heat, temperature, heat 3 times. So when I look for trends, right now I see 2 things, materials and heat. What is the temperature? So does it make sense for us to investigate those 2 questions next? It's kind of where we're going. And so let's just stop and reflect a minute. What we just did is the science and engineering practice of asking questions. And if you haven't seen this document yet, you definitely need to familiarize yourself. This is a planning tool, and this is number 7 in your dashboard. So if you go to the dashboard, click this document and open it. It'll take you to our website where we have this housed. And on this very first page is the science and engineering practice of asking questions and defining problems. We did not define a problem because we're not in engineering. That would be a U2 standard. We're in U1, which means we're asking questions. And each of these bullets explains the skills necessary to accomplish this at that grade band. These are called elements. And so elements are these specific pieces of knowledge that make up each practice. When I go to sit down and plan a lesson, this is the document I go to say, if I'm asking questions, what really am I going to have the students do about asking questions? And it increases in sophistication over the grade bands. So each of these bullets are just kind of explaining what the students could do in that grade band to reach this science and engineering practice. And so I took off K2, and I want you to look at A, B, or C and just do a little reflection before we move on in the investigation and start figuring things out. So which of these elements, A, B, or C, do you think that we engaged with right now, just in asking questions? In the chat box, and we don't have to do a waterfall, that's okay. Go ahead and write what you think in the chat box. Do you think we did A? Did we do B? Did we do C? And you may hit enter whenever you're ready. We have B, asking questions from phenomena. Lots of B's. All right, and so since this is a middle school one, we really are kind of in this asking questions about the observations of phenomena. But sometimes when I'm planning, I could go down to 3-5, and maybe my kids, look at this, we've asked questions based on careful observations of phenomena. That could really fit there too. And so remember, you can always go back a grade band and kind of look forward and kind of just see where are your kids at. And so on the teacher side of things, when we're asking questions, there's a purpose. It's intentional. You're going to use, I know with my teacher hat that I want you to use the evidence from data to create the model, which we're going to do next. But all of it is connected to why does the ice melt faster on one block than the other? And on the student side, like, why do we have kids ask questions? Well, now there's a need. I've created a need for us to go, wait a minute, we have these questions. We need to figure this out. And so now the kids are invested in going, I want to know what the materials are. I want to know what's up with the temperature. Let's go investigate. And now the kids are in the driver's seat and they're going to push the instruction with your guidance to where it needs to go. And so if you're wondering where I got some of those questions I was asking you during the video, it's literally in the daily do. So this is what I mean. Do you see the See, Think, Wonder table? All of these tools are in the NSTA lesson that I'm using with you. So I just wanted to point that out. There's a lot of guidance here if you're new to sense making to help you along. All right, so now we're going to move forward into the investigation. And if you look at the waterfalls with our trends and our questions, we all want to know, what are the blocks made of? And does it make a difference if they're made of the same things or not? And what about the temperatures? You guys came up with that. But me as the teacher, I knew that that's what was going to happen. So does it make sense we investigate the questions about the materials and the temperatures next? The answer is yeah, let's do it. And so what comes next? Oops, this kind of looks funny. With students, you would ask them to go to in their house and find something from group A and group B. So take a look at the items in each of these and start thinking about it. And this next segment is going to be short. We don't have time for me to walk through every single thing, so I'm going to kind of high-level overview this with you. And what we're going to do, if you look, you can start to make an inference. Everything in group A is a metal. Everything in group B is non-metal. And the kids are going to go, aha, I noticed that. Everything in A is metal. Everything in B is not. And you're going to go, oh, okay, yeah, great. Let's go. Let's go find these things in our house. So what you have the kids do is you find something from A, something from B. And then in the daily do is this data table. And we're not going to collect all of this data. I'm just going to walk you through what you would do next. Because remember, we got to gather some data now to help us figure out what's happening. So this is investigation 1. And what you're going to do, you're going to find those objects, one from A, one from B. Then we're going to start with initial observations. Take the room temperature. And hopefully kids have thermometers. And we'll talk about that in a minute. So we're going to do temperature. We're going to touch the objects, describe how they feel, and we have to take the temperature of the object, which means you're going to need thermometers. So if you are doing this with kids at home, you have to be mindful of, do they have a thermometer and what are you going to do if they don't? And so we want students touching these objects, using a thermometer if they can. And so if you don't have thermometers, we're going to talk about that in just a second, about how you can do an alternative. But since we were worried about temperature and heat, we're going to need some numbers around temperature, since that's what we wanted to figure out. Then we're going to talk about, what do you think is going to happen? And what the kids do is they grab 2 ice cubes and put them on those materials, and they repeat the same kind of thing they saw in the video. Then what really happened? How long did it take the ice to melt? What else did you observe? So they're really doing what they saw in the video at home with new objects, one metal, one not metal. And they're going to collect all this data, which then they're going to analyze it. So here comes in the next science and engineering practice. So for the investigation, the students choose objects and then they're going to have to measure it. So if your kids are at home, consider grouping your students by thermometer availability. You might have some kids who have thermometers, you might have some kids who don't. And so one way that's really easy to figure this out is make a Jamboard and say, if you have a thermometer, go put your name on one of the frames. And so someone goes in and then you assign a couple kids to each Jamboard that's available. You can put them in breakout rooms. You have to figure out logistically how you're going to get kids. Let's say you had 5 kids with thermometers. Well, we can do some group work. Okay, let's get in a Jamboard. Let's work together. I mean, there's a billion ways you could do this, but you have to be mindful. If your kids don't have these, what are you going to do? So the best thermometers are infrared, aquarium type liquid, but meat thermometers work well too. The kids just need to know that they have to touch the thermometer to the object to get the correct reading. So once you've figured out thermometers, they put the ice cubes onto the 2 blocks and then they make their observations. So again, just think about thermometers. And then if you don't have thermometers or you don't think your kids can get to them, that's an equity issue, right? And so we don't even want to do that. So what could we do instead if kids don't have thermometers? There's an alternative. There's a video in this daily do where somebody has a thermometer and they're gonna do the temperature for you. So there are alternatives is the point. And in the video, you after you have the kids do this video and they collect all the temperature data, they learn that one block is actually plastic and one block is aluminum. So now they're starting to figure out a couple of the questions that they asked. And so let's pretend we were in the alternative world and I asked a student to get two different objects to at least reach out and touch something metal versus non-metal, because they can collect that data for the data table about touching the objects. So there's some things that they can do to make it hands-on, and some things you might have to rely on the alternative video for, which is fine. And through watching this video, they will be able to fill in the information in this table. And then if they touch a couple objects, they'll be able to fill that in too. And so here, I just kind of sprinkled in what I thought would happen with objects after watching the video. So I went in and I did all this data, but this is essentially what the students would do through touching the objects that they could find and watching the video with the alternative temperatures. They'll find out that the room temperature is the same, the temperatures of the objects are the same, and what is different is, the kids are going to come up with different answers here. And then they're going to notice that something happened with something in group A versus B. And really, when we walk kids through analyzing and interpreting data, that's this science and engineering practice. And if I ask questions about patterns, that means I've already engaged them in a cross-cutting concept. And so after you had the kids do that, you would go back to the Jamboard and you would add in more observations and patterns. So remember, the Jamboard is there. It's like a keeping track of everything we're learning. So you would return and then do it again. And so the intentional use of analyzing, interpreting data is really important. And so here, we're not going to do the chat box. When you sit down to plan and doing this kind of work, use these tools to think about, what do I specifically want my students to do? So here, interpreting data to make sense and explain phenomena. That's a practice, that's an element. And that's what we're going to do through this activity, which are tools in your toolbox. Okay, so now we're going to move into another collaborative space. Now that we know a little bit about, okay, we have different materials. One is metal, one is non-metal. We now are going to ask the kids to go back into the alone zone and create a model. And this is exactly what it says to do in the lesson that I picked from NSTA. So you have the model. Here is like a macro view of the model. And then here we have a zoom in on the touching. We want to know what's happening, because remember, this is about energy transfer and something has to be transferring right where those two things touch. And so what we're going to do now is I'm going to show you how to do modeling using Google Docs for collaboration. So go to number 10 in the dashboard. So dashboard, here we go. You're going to click, actually, I wonder if we all, why don't we all, let's see. Let's not use these. Click on either December, February, or April. That way we have at least enough people in there to do the work. So don't use any of these. Only use December, February, or April, any of these. And so I'm going to open this up. So please only go to December, February, or April. And when you're ready and you're in one, just write ready in the chat so I know I can explain what you're going to do. Ready, ready, nice. Thank you. Ready, ready, ready. Fantastic. Okay, so remember, try to only go to these three. So if we can get some folks in, ignore your birthday month. And let's just get people into these. Okay, more people are ready. All right. So what this is the alone zone and small group work all in one doc. And so you can see the example I have here. And how this works is, this is just an image. I screenshotted this and I went insert image, or no, I'm sorry, insert drawing, added in a new drawing so that when you click this, check out what pops up. You see this edit button? Edit means I will be able to draw what I think is happening and why the ice is melting. So on one side, we have the metal. On the other side, we have the non-metal. And so we have to think about what is happening. And so just to remind you, let's come back. Go back real quick. One is plastic, one is aluminum. And let me show you this really quickly. So plastic is on this side, aluminum is on this side. Same temperature. Or I'm sorry. This side is aluminum. This side is plastic. So we're going to draw a model about what we think is happening in this contact space. Why is this melting? What's causing it to melt? And this is the alternative video. So if your kids don't have thermometers, and it takes about 7 seconds for it to melt. And so aluminum is on one side, so we have metal and non-metal. So that can get tricky when you come to the models because I have metal on this side. So metal's on this side, non-metal's over here. And your job is to use these tools. You can use shapes, arrows, callouts, equations. You can use lines, all different kinds of things to open your model. And then, like what I did, I put little particles here with arrows. And I said, I think thermal energy is, transferring upward. And I just used these tools to create this little model. So what you're going to do is here I have group 1. And you're going to go put your name in a space. So I put my name here. You're just going to scroll down. If you see an open spot, put your name there. Scroll on down, open spot, put your name there. And then go ahead and start drawing your model. I'll give us about, 3 to 4 minutes to start drawing your model. And again, the way you edit, click the image. Then since it's a drawing, edit pops right up and I can open it. And we're just going to go in the alone zone. Now, you are by yourself trying to figure out what's causing it to melt faster on the metal one than the non-metal one. And so grab a space, put your name in there, and then go ahead and start editing your model. What is causing it to melt on the metal side versus the non-metal side? And you can draw any way you want. And if you get ready and you're like all about this, I left you a space to start constructing an explanation. What's causing that to happen? You can start typing out what you think is happening here in the space that says explanation. So I'll give you 3 more minutes and I'll put a timer on. So the edit menu, if you are looking over here, it's not supposed to, so when you click, you'll see it highlight edit, then you click edit. So if it doesn't open, can you try to go to another space maybe? You have to click on the image first for the menu to pop up. I'm not able to type anything. Julie, can you, do you not have editing rights, or do you mean in the drawing you're not able to type? You don't see the edit menu. Which one are you in? Okay, can you guys tell me which, what doc you're in, like what birthday month, so I can go look what's happening? First room. Sarah, can you try them? And because I know I'm in them. So the dashboard, do you have it downloaded as a PDF? So if you have the link, you definitely cannot open this as a Google Doc because it will start to get funny. Just download it as a PDF.
What I would suggest is click on, like I'm on the second one after yours, Rebecca. So if you click on the image, so I just clicked on the image itself, and then I see the edit button underneath now at this point. So click on the image, then click edit, and then you can add any of the things to it.
No, I know. You guys, I put them all on edit to begin with. So which one are you on? Because I don't know which one you're on, and I can't fix the edit if I don't know which document you're on. So is it December, February?
This one won't edit. So here we are with the first one, which was December. Anastasia is group 2, the very first one, and she said this one won't edit. So
okay, because it is on editing. I'm looking at it right now.
Well, I just clicked the image and then I just press the edit button and then I can make changes.
Right, you have to click the image first and then there's an edit button here.
Can I interrupt? I figured out what was going on. I was one of the people having issues.
Okay.
I found that in the top right of mine, underneath where the share button is, I didn't have it on editing. I had it on suggesting. When I changed it to editing, it worked the way you were showing. And I don't know why it came up as suggesting in the first place, but that was what fixed it for me.
Okay, perfect. Thank you. Does everyone see the button she's describing here? So if it's on suggesting, you're going to get that green writing that pops up like you're tracking changes. So editing, you need to be on editing. Okay, the permissions should all be edit. So I don't know why. Philip, which one are you in? I don't know. It shows as a comment. Do you have on viewing? Have you checked one of these to make sure it's good? Okay. For those of you who are, I'm gonna try to kind of move us along just because I know there's some people, this one won't edit. When I click on it, the edit button pops up. So let's make sure that we're clicking on the image and then clicking edit, because I can do that one. This one doesn't. I don't know if there's too many people on this one and that's what's causing trouble. Okay, maybe try to go to one that doesn't have a lot of people, just so you can kind of familiarize yourself with the tool. That's my only other.
We're working on February and March. That's the one I'm in, and there's a few people in there that are drawing visuals and writing their explanations.
Okay, perfect. Thank you. Because it's hard for me to troubleshoot all the issues on your own end. All of them should be open for editing. Just make sure that you have this on. I see people drawing some things here. Okay, we have some people drawing. Got some large molecules here, which is great. And then we don't have time to spend, like if I were doing this with kids in the classroom, this would take probably like a whole period, right? Just focusing on modeling. And then what I would do is if the students had, their models good to go and they started to construct their explanation, what you move on to is small group collaboration. Because remember, we want the kids talking to one another. And if you've already got your groups created, you can make these bookmarks so that it automatically, group 1, go there, group 2, go there, group 3, go there. And they're just, bookmarks down, and it'll just move me down to the next group. So you need to think about, like, how are you going to group kids? How are we going to do this? But once they've got the alone zone part done, where they committed to their own thinking about what is causing that one to melt in the metal side, and they construct an explanation, you want them to interact with each other. So one way to do that is to use the comment feature. And you can see here that I've added some sentence starters for the kids. They always need sentence starters, no matter what grade they're in. And so what I want them to do is to identify one similarity and difference in someone else's model in their group. So if I'm in group 1, I'd go down and I'd look at everyone else's and I go, oh, look at this. I see this. I'm going to put a comment. I noticed I used circles for particles like you did or something, right? And I would have the kids write, like, what is the same? So that would be like, I noticed something similar. And then I would have them do, what is something different? Like, oh, maybe you added arrows for energy transfer and someone else used squiggles or something. So we want kids talking to each other about models. And one great way to do that is just use this comment feature and provide sentence starters. I noticed one thing similar. I noticed one thing different. And they're just working within their own group to provide that conversation. For the second one, ask the kids to go and ask a question about the model. Because remember, we need to understand each other's thinking to come to consensus as a whole. Like, what should go into our models? Oh, we all had arrows. Maybe we'll all have arrows in the class, that kind of thing. And so I provided some stems here for questioning. Why do you think that? What's your evidence for? Can you please clarify what blank is in the model? So while I wish we had hours upon hours and hours to do all of this work, we don't. But I wanted to show you ways that you get kids to collaborate for science and engineering practices in one space. And again, the reason we broke out the groups is too many people on one doc will make it fail. So that's why we went with birthday months. You could easily do the same thing and make different groups as separate docs. And so this is just a really great way. And the way you enter in these images is all I did, insert, drawing, new, and then I pasted it in here. That is how you get the edit function to function. And that's it. This is just a screenshot. And then you'll get the edit button once you insert it as a drawing, not an image, but a drawing, because that's how you get the edit feature. Okay, so we are going to come back and really move forward here and just think about, we started getting into another science and engineering practice of developing and using a model. To develop a model means it's not one and done. I'm going to develop it over time, and I'm going to talk to people and collaborate with my peers, and then I might come back and refine my model. But then I'm going to use it to construct an explanation and use it to explain what's causing that phenomena to happen. So developing and using models is really an iterative process. I'm going to start with an initial model. We're going to do some learning. We're going to come back. We're going to fix some things. We're going to decide as a whole what things should be in our model. Maybe it's circles and arrows and squiggles and whatever. And we move on. But remember, all of this is intentional. Whoops. All of it is intentional. When I sit down to plan, and even though I am not the planner of, I did not create this lesson and we don't know what they were thinking, as the creators of our lessons, we need to choose the element we want kids to be engaged with. And for this one, develop models to describe unobservable mechanism. We can't see what's happening, so we have to draw it and figure it out. And so how do you keep moving kids forward in this investigation? Well, now we've got some models. We've asked each other questions. We're starting to figure some things out. Many of us still want to know why they're melting at different rates. And so from those models, you're gonna exit that modeling experience with a path to move forward. And your job is to guide the kids there. And really, this is just the basic design. We're coming to the end of the webinar where we just wanted to show you some tools on how you can engage students with the science and engineering practices. But think about it. Did we engage in phenomena? How about science and engineering practices? Did we talk about student ideas and have you in the alone zone first? Oops, sorry, I was trying to admit someone and I turned off the screen sharing because it was in the same. Sarah, can you admit those folks, please? And so we had phenomena, we had many SEPs, we had tons of student ideas, and I kind of set up classroom norms for you at the beginning, but then I also scaffolded the process to say, now you're going to circle, you're going to put an arrow, you're going to put a comment. I really, these are norms for collaborating. We're always going to talk to each other. We're always going to evaluate each other's models. We're always going to ask questions of each other. And that is what is expected. And so we really did all these things in a short amount of time, but all of that was sense making. And of course, it won't happen in just an hour or 75 minutes. It will happen in multiple days of learning. And really, we have to think about this design. Sense making requires intentional choices. How are they going to, engage with the phenomena? What materials do they need? What tool am I going to use? Am I going to use docs? Am I going to use Jamboard? Am I going to use a Padlet or, whiteboard, whatever you use? And sense making at a distance is really about choosing the tool that will get the job done, not just the new shiny thing that somebody wants you to use or that your kids may not know how to use. So really think about what the students are doing. And this is what we call flip upside down. We no longer are teaching in this traditional way, thinking of the scientific method. That is gone. We have moved away from that. This is the old way where teachers gave knowledge to students, but it only really reached some of them because it was all based on isolated facts and the scientific method, really, which is not how we learn science. It's how scientists actually write about science once they've done this iterative investigative process. And where we're at now is the students act as the scientists and engineers, where they're making sense of the phenomena and the teacher is on the side as the guide. This is how we are going to engage all students. It's a heavy lift for teachers, but it's also a heavy lift for students. And together we struggle through it. And so we're going to show you one more strategy for questioning. This is called STACK. And so just to review digital strategies we used, here is a list of all the things we did. The final one is what we call STACK. And so this is like if you have kids using a chat box, if you have trouble like raising hand feature or a way to get kids like who raised their hand first. It's called STACK. All you're going to do if you have a question that you want to ask right now, you're going to type the word STACK into the chat. And what that does is it stacks people up. It builds a virtual line for me to go, oh, Sarah's on STACK. Sarah, ask your question. Or, Carol's on STACK. And it just provides a way for kids to know who comes next. And if they want to say something, they have an opportunity to go. So this is the end of our webinar. We have 2 minutes for questions. If you want to jump on STACK and ask a question and unmute yourself, now is the time. I'm happy to answer questions. And Sarah, I'm assuming you don't have a question. Does anyone else have a question?
I don't have a question, but I did put the information in for the PD clock hours that you're going to receive a survey to fill out, and then you will be able to obtain your PD certificate. After Rebecca puts in the, fills out the attendance, then it goes into the next step, and that's when you'll get the email. And we don't print those certificates out or send those to you individually. They go through the EMS system.
And no one has questions. Okay, no worries. All right, that's it.
Questions for Rebecca while you've got her here, folks.
This is my first time. I've never had questions. Yeah, all right. Well, thanks for coming. I hope you learned a couple tricks, tools, ways to do modeling. Kids can do it. You just got to set the norms, set it up. Okay, good. Sorry to all of those who had tech issues. I really wish I could fix all of those. All right, a reminder, it takes me a little bit of time to put in attendance, and then you'll be able to print your certificate. You'll know because I'll send you an email.
Hey, Julie, did you have a question? I don't know if we couldn't hear you.
I have a question, Sarah.
Hi, Monique.
Hi.